Hello friend, today we are going to extract the cross section from the solid body and use it for analyzing of the beam. The last time actually I have shown you how we are analyze the beam in the Ansys, but there we have used the cross section defined by us. Okay, now today we will go and extract the cross section already from the solid body. So first we are going in the static structure, drop the static structure into the standalone create. Here we are putting the beam, BEAM, beam for cross section extraction, okay. Engine data does not matter. It will be the default structure steel. Now in the space claim geometry. In the space claim geometry, it is the Ansys CAD tool. Let's see how it is opening there. So here you can see there are so many modules are there. We have already completed the transient thermal. We have completed the steady state thermal. Now we are going for the static structure. Then we will like that we will go for model analysis. Like that we will move. So here is the Ansys space claim. Here what we are going in the XY plane. We are just taking the sketch. In the sketch we are just taking the rectangle. Okay, defining rectangle from the center. Okay, we are going to take 50 tab 50. Okay, I am just taking the, actually I want to make the trapezoidal instead of 10, this 10, 10, click it here, escape, then use the trim tool and trim, can remove it like this, just return to 3D mode. In 3D mode it has created a surface, this surface, enter the space bar, put 1000 mm. So this solid bar has created. You can see here the solid has there, just rename it trapezoidal. Trapeze. Okay, this is a trapeze. Till now I have just drawn a cross section trapezoidal beam. I want to do the analysis on this beam. I can draw the eye cross sections. I can draw the any cross section. Okay, so it is, I have this type of beam is available. Now I want to use it as a beam element. How I can use it? You can go in the prepare. Here already profile are there. Here already the trapezoidal profile will be there. Okay, but I have not used it. I want to show you how to extract. So there is a second term called the extract. I have clicked the extract. So here instruction come, click a solid body to attempt to extract a beam. So I have clicked the solid body. Okay, I have clicked the solid body, then it will go and extract it. Oh, it has extracted actually. Okay, so here you can see the beam has extracted. In front of the beam that is showing the eye cross section, but it is actually a trapezoidal. Here also in the extracted. You can see here the solid is still there, so that is not required. You can go and you can delete it. Okay, if you want to keep it, you can keep it. You can go and check the extracted profile by click it and say edit beam profile. You can come and you can see here that it is having a trapezoidal. If you want to change the cross section, that option actually they have not given here. Why? Because it has taken your cross section there. So the all the dimensions of that is the whatever you have decided. Okay, so here we have got the beam from that solid. Now we are taking it, we are going back, already the geometry is there, double click in the model. In the model we have to apply the material, we have to mesh it, we have to apply the boundary conditions, and we have to find out what we are going to be finding, stresses, strain, deflections, whatever. So it has opened, Ansys 2020 R1 has opened. Here is a geometry. You can see extracted profile 1. Okay, here it is flexible, material is default, that is a structure steel. In material, the structure steel is there, cross section. Okay, material is a structure steel, bulk modulus, iron modulus, that is 2 into 10 the power 11 gigapascal or 200, sorry, 2 into 10 the power 11 pascal or 200 gigapascal. And you can go, and if you want to see the cross section actually, are you interested to see the, this is the option for the cross section here. Oh, it has come with a cross section like this. Okay, so I am going in meshing it. Insert sizing. Here the only the sizing is important, and automatic, which is selecting the whole length, edge, element size 0.001, that is a 10 mm. 10 mm is good for me. So 1000 divided by 10, so 100 element will generate the mesh. Statics 100 elements have developed. Insert fixed support. Here you want to fix it, so take the vertices here. I took the vertices. Then I am going apply the force. I want to apply the force on the hole, that is UDL. I've applied by surface effect, defined by component. In component, I want to apply it in positive. You can see it here. I'm applying here, that is the negative y direction. Direction minus 6000 matlab 6 kilonewton per meter. Okay, and we are going to solve it. Solving means we are solving the 3D equilibrium equation, differential equations on each element and solving it. Ansys is doing that work. Deformation, directional, not in X, we are want in the Y direction. I'm interested. Okay, there will be some deflection in the Z also. Okay, that you can see. Deformation, directional in Z, and you can go and find the prob. Mainly in prob, it is good for you to go and see the force reactions, whether you are getting the same force what you have applied or not at the fixed end. Similarly for the moment, insert probe moment reactions for your checking whether you have got the same thing or not. Okay, so evaluate the all results. In directional deformation in the Z direction, so you can see, sorry, in the Y direction it is 6.0693 mm, that is here. Okay, and directional deformation in the Z direction, actually in the Z direction where the beam is there, it is showing 0. Okay, force reaction, it is 6000, the same what we have applied, and moment is how much? The moment, that is 3000 Newton meter, because it 6000 we have applied the UDL. So according to the UDL, that should act at the center, that is 6 into of that is the half, that is the 3000. So 3000 Newton meter it is acting. So like this we can analyze we can extract the cross section from any beam and use it for our analysis. And one more thing, actually in the same thing, actually I want, okay, in the next video I will explain that. Thank you friends, this is Deepak Maurya.